1995. Every day that I came back from college I had the opportunity to meet a wonderful man. This person with whom every day we would read poetry or talk in Latin. I had the opportunity to meet a wonderful man, this person with whom every day we would read poetry or talk in Latin. And I remember how I would say to him, and he would tell me that your verses are stellar. He had to leave the region, his farm that was on the banks of the Black River. He also used it to grow aloe vera plants, these plants, whose varieties are Barbadensis Miller. He had brought them from the Dominican Republic, and he took care of them with a wonderful care. Juan once told me I must leave the region. I am very old, the cold hurts me. But I will give you your future. And he gave me 100 plants of aloe vera stalks. I started to move to a little house where I lived in Rio Negro. And very soon I had 10,000 plants already cultivated. And obviously I did not have any industrial process. Precisely on the day of my daughter's first communion, I was visited by a technician from Vitas Petroleum, Dr. Miguel Dario Ramirez. Miguel Dario Ramirez Navarro. He was surprised to see the cultivation of aloe and how important this crop was in the southern U.S. We began a process of research, initially monographic and then trial and error application of how to extract the aloe vera gel. This process that began in 1996 has not ended. And we are still learning. Because every day not only appears a new property of aloe vera, but we find new ways to transform convenience products for health and nutraceutical food. Initially we wanted to democratize the cultivation, to invite other farmers to plant with us, because the first intention was to export the aloe vera gel. Today, 25 or 30 years later, we still have a learning process in the export process. This is a very beautiful story, because it was born as a life project. Family project where all my family converge, my family nucleus, my father, my sister, my mother and myself. Have been researching aloe vera for more than 30 years. And that has generated a life project that has been built from the planting, the transformation that is a necessary requirement for this process that I am going to show you, which is a bottling process. Today we are technifying the bottling in liquids. Not only with aloe vera, but with fruits and other promising natural resources. And we are the solution for many people who want to bottle and who want to give a transformation to their product. From some monographic work done by the JAX International with zinc, which is the entity that gathers the largest amount of technical and scientific information on aloe vera, we have been extracting from there, but obviously also from the ancestral experience of many farmers who have collaborated with us on issues of fertilization, on distance, on issues of allelopathy, that is to say, aloe must be grown with other varieties to ensure its phytosanitary quality. That is to say, when we associate crops, we also associate the biome. That is, insects, worms, butterflies that undoubtedly form a circular economy because it is the maximum use of nature's resources. Well, within the range of sectors that have green businesses is the agro-industrial sector. In this case we have a food agro-industry, and a non-food agro-industry, which have in common that for the development of their products they use raw materials of natural origin. In the case of aloe vera, it is an example of a crop that allows us to have an example of a crop that allows us to have in a single crop as well as applications in food agro-industry, non-food agro-industry. In the case of the company TvAgro Naturaleza, they are in charge of processing these are in charge of processing these crops to make the transformation of the aloe leaves, and to elaborate from this raw material different products, some for food and others for cosmetics or other applications. In the world today there are about 250 varieties of aloe vera. Commercially only 6 have stood out for their high productivity, and within the 6 aloe barbadenses. Miller is the variety that most interests us commercially, and the aloe vera industry is most interested in it. In the field our first process begins with sowing. The hole we open is 40 centimeters on each side and 40 centimeters deep. We treat the hole, and after treating the hole, we apply a kilogram of organic fertilizer, in which we go to sow a seedling that has been in the nursery for between 3 and 4 months. This seedling that has between 8 and 12 leaves is the one that we initially put on the ground. From there we begin some tasks of fertilizing, cleaning the seedlings and collecting the flowers. After a year we clean the most apical parts of the plant to allow the leaves to grow. We get the first harvest after 3 years. While those 3 years we have other leaves that we also process, but we use them for other purposes, especially to make products for the field, to be rooters, to do irrigation. After 3 years the leaf we harvest. We carry out a process in the field, and it is the first extraction of aloe. Aloe is a compound that aloe has, a compound to enter that is anthraquinone, anthracenic. You have to isolate it from the plant, because when there is a lot of it, other than that it makes the product very bitter. The product can be a product of toxic epate. That is, it can accumulate in the liver and can cause problems. For that reason the first olination is carried out in the field, which consists of extracting a little of the aloe. Then in the plant we bring the rest of the aloe. Already using some products that we have developed, that we have investigated for the total extraction of aloe. That is the yellow liquid that people commonly confuse as iodine from aloe. Aloe contains organic iodine, but in a very small quantity. That is to say, this organic iodine could even be taken into account in the diets of people who suffer from thyroid disease, because those who suffer from thyroid disease require iodine in their diet. In addition, many other compounds, for example, aloe vera, have an amino acid called tyrosine, written with S. which is the amino acid that the body requires to be able to produce thyroid hormone. So many times the problems of thyroid dysfunction are due to the fact that our food is not resources that our body requires to manufacture that hormone. Every time aloe is investigated, new properties are found, because in this plant there is such a variety of elements that we have vitamins, amino acids, sugars and even fats. The sterol fields that aloe vera has are fats that the body uses to make hormones. But it also has trace elements. It also has minerals. It has enzymes. It has coenzymes, and it has complements. This variety of compounds that aloe has have made us recognize it ancestrally as an element. That is, a plant that is absolutely necessary for nutrition, which is a little different from food. Us in the family and circular economy that we have in our company, which takes into account the entire chain, the production chain of the raw material, and of the transformation. We take into account that we manufacture food of benefit to society, to humanity, so that we are also contributing to the best nutrition of all those who use our products. My name is Ruben Dario and I have been here for 15 years, here in the PHPI company. Since for 15 years or so I have been working in agriculture here with the penca. Besides, everything I like is planting. More than all the penca, I practically come from a peasant family, my parents more than everything and my grandparents. He came in at 8 in the morning. From 8 to 5:30, I come here more than anything for cleaning the paddock to plant it, and maintenance and all those things. And the company more than anything, he has given me training. Don Umberto Pelaez as well. To harvest it a process of 3 years more or less. Already in the 3 years one already begins to tear off the leaves, already to process it in the plant, and that it has a height more or less around 40 and 50 centimeters more or less. And there the Matica already shows you the size as it looks to tear off the page. In this circular economy process, we at the plant carry out the second link in the chain, that is, the industrial transformation. The raw material, the aloe vera leaf, arrives at our plant in a washing area, where it is weighed and the process is carried out. Deweighting, so that the raw material begins the process by which we obtain the first raw material, which is the asabar. We simply arrange the leaves, and by gravity an important part of the asabar comes out that we use in other processes. From the part where the asabar comes out, we return to the plant where, through a wash that we carry out with substances that we have thoroughly investigated. Basically we work with enzymes. We try to extract the highest possible proportion of aloe. And at this time we work under an international standard, in which we have only 1.5 parts per million of that product. The reason is that it has been thoroughly studied that large amounts of aloe can cause accumulation in the liver and therefore possible hepatotoxicity. After we proceed to remove the aloe that is simultaneous to the washing process, we go to a rinsing and disinfection process. After this we remove the leaf in baskets and enter the plant where we are going to make the extraction of the fillet. To obtain the fillet from us, we initially cut the spines that are on the external parts of the leaf and remove the first rind. This process is done manually. We previously carried it out in machines. They did not give us neither the yield nor the quality. And for this reason we decided to go back to this manual process, where we see that it ostensibly improves the quality of the product. Then comes the filleting. Also using a technique I would say ancestral, we extract the fillet and we arrange that fillet so that it is previously weighed and goes into a pot where it will be heated through the steam generated in a boiler. After heating the product goes to a Swedish shaker where we try to divide the raw material into two. One part that is the fillet, and another part that is the gel. We use the fillet that remains on top of the Swedish shaker to pack it as a fillet, and we market it that way, or to remove the pieces with which we make drinks that today have a very good course or very good competition in the market. After we have made this quality control procedure takes a sample through a test that an external laboratory does. It's called photospectrometry. We can know how much amount of aloe contains the product. This test we do in laboratories. External releases us the product that we have as raw material in a cellar where we keep that raw material at 7 degrees centigrade until we use it in the manufacturing processes of our products. Now for the elaboration of the products we have this plant. It is a plant approved as a food plant by Envima where what we use and what we take special care of as raw material is water. We through a system we enter it. We store it in the company. We treat it basically by gravity. We precipitate some solids that they may have. We have never found them. But the mechanism guarantees that it can separate solids by gravity. We bring them to this plant that you see in the bottom. And in that plant we carry out a second nanometric ultrafiltration in order to obtain excellent quality water for the manufacture of our products. As you can see in this plant we basically have a filtration that is made with zeolites with activated carbon. With what is called lamellar filters. We get to filter the water here from a point of 5 microns to a 0.1 micron. We submit that water to another process. This process is called reverse osmosis, which is a process through which we guarantee the quality of the water. When we already have the water, quality control comes again, takes a sample, and based on that sample where we do a microbiological and a chemical physicist, we release the water for production. We are trying to use a PP container that is a totally recyclable container. A preform type container that allows that later with that container it can be managed the manufacture of walls and infrastructure works in the civil part. And finally we use glass containers that are totally recyclable. In this way, based on the axis of a circular economy, we take advantage of 100% of the resources that enter our plant. There is something that happens with linear production systems that is what is sought to change over time, and that is that these linear production systems are unsustainable over time, because they assume that we have infinite raw materials. They seek greater demand, but that it implies that we also have a greater demand for raw materials and resources, and we have only one planet, and that is unsustainable over time. So that is what is sought to change with these new production systems, such as those of the circular economy, in which it is sought that all these waste byproducts serve in turn as raw materials for other sectors or for other industries.